This video is not to provide a detailed analysis of formulas or to train skills in operations with vectors and matrices. We will only scratch the surface of understanding simple basics to prove that any person with a minimal mathematical knowledge can get an idea of machine learning essences. Linear algebra has taken its place of honor in many fields of knowledge, such as computer science, quantum computing, physics, statistics, electrical and mechanical engineering, and so on. For now, we only need a part of it: vectors, matrices, and operations with them. Once you gain the understanding of vectors and matrices, you can apply this knowledge to machine learning and beyond. Moreover, if you cover trigonometry in addition to vectors and matrices skills, it will be easier for you to enter the field of 2D and 3D programming as well as robotics. Ideally, we should aim to get a geometric understanding of all entities and operations in order to get intuition to solve any problems, not just those mentioned in this video. Since the computing system has no idea about objects or events in the human world, we need to explain those to it. At this stage of machine learning development, vectors, matrices, and tensors are the tools to help. These are the fundamental concepts and the main drivers of the systems that we are going to discuss further. They will be the ones to make the computer understand, for instance, what is mentioned in the text or what is drawn on the picture. What is the difference between the word king and the word queen, and how a celebrity photograph is different from a bathroom selfie with a shower curtain on the background. A short description of vectors would be two numbers that indicate the starting point, the ending point, and the distance between. The concept of a vector may vary slightly depending on the knowledge area, but the essence remains the same. For instance, in physics, vectors are often taken as maps of motion or flows, while in CS, a vector is seen as a description of an entity. In mathematics, the vector is as abstract as possible and can be converted into any convenient form depending on your goal. The vector is determined by at least two components. A single number refers to a scalar. If there are three components, then you are dealing with a three-dimensional vector. Of course, there may be four components, and more. You and I are locked in a three-dimensional space, but our calculations are not. Therefore, you can't visually present a vector in a four or more dimensional space, but you can still calculate it. Vectors can be subtracted, composed, multiplied, by dividing a vector, we mean its multiplication by 1 over x, where x is the number by which we want to divide the vector. Let's see how this works through an example. We have an area of concepts you want to interact with, and that are already converted to vectors. These are a few words that carry a certain meaning. For instance, you want to know what the result will be if you subtract the man vector from the king vector and then add the woman vector. As you can see, we got the queen. Or let's say you want to subtract the essence vector from the dissertation vector, and then you get the flood. Vector can describe other concepts, for example, a person's spectrum of tastes and interests through tracking his or her website visits and reaction to social media content. The interconnection of several structures can be put in a vector as well, creating what we call embedding, a topic that deserves special attention in several videos. I'm sure you're making the right guess now that if you have a good dataset, anything can be encoded and exposed to further mathematical operations. An image can be represented as a vector as well, however it's not effective. If you transform a 500 by 500 item into a vector, you will get a vector with a dimension of 750,000. Therefore, matrices are the ones to be used for images and for computer vision in general. A matrix in its essence is just an array for a developer or a table of elements consisting of rows and columns for a mathematician. Matrices can also be subtracted, added, and multiplied. It is impossible to divide the matrices by each other, but one matrix can be multiplied by the inverted second one, which may also not work in some cases. A tensor is a multidimensional matrix or a multidimensional array. For instance, if we decompose a colored image into 3 matrices, each representing one color channel, and accept the 3 matrices as one object, it will make a tensor. Within the tensor, you can store not only a matrix, but another tensor as well. The number of tables inside the tensor determines its dimension, and its elements are called tensor components. Tensors also have their own properties, and mathematical operations that we mentioned earlier can also be applied to their components. Of course, vectors and matrices have more complex and defined types, and there is a variety of operations to be applied to them. For now, we will stop here. Now you know a little bit about scalars, a little bit about vectors and matrices, and a little bit about tensors, but summing it up, you already know quite a lot. These elements will be the fuel that will flow while consistently transforming through all those models and systems of machine learning that we are going to study next.